So far, we have used several types of built-in data types, including integers, floats, strings, lists, sets, tuples, and booleans. This video introduces another handy Python data type called a dictionary. Before we delve into dictionaries, we'll briefly review Python lists so that you'll be ready to compare and contrast the similarities and differences between list and dictionary syntax. As a quick refresher, write down a line of code for each of these 5 tasks. Create an empty list named MyList, append 8 and 5 to the list, and so forth. Pause the video now to complete your answers. These solutions are in the note view. Create an empty list with empty square braces and use an assignment statement. To append 8 and 5, you need to use 2 separate append statements because the append method can only take one argument at a time, or you can use the extend method, which takes a list as an argument. Since lists use zero-based indexing to get the second item in the list, we say my list of 1, and we set x to that with an assignment statement. The keyword in can be used to check if an item is a member of a list. The keyword in can also be used with dictionaries. Dictionaries do not use indexing, but they use something that looks similar to that, and we'll discuss that in a moment. To loop through a list, you can simply pick a variable name for the iterator and say for that variable name in the list name, and then you can do things with that variable inside of the loop. You'll see in a moment that the dictionary has very similar functionality for loopability. Before it became so convenient to look up word meanings on the internet, we used to use dictionaries, sometimes really big dictionaries, 10 inches thick. Words would be organized in alphabetical order, and each word would have a derivation, a part of speech, a definition, and a list of forms it can take. To look up the word insouciant, for example, you'd flip to the I section and find its entry. There would be only one entry for insouciant, though it might have more than one meaning. All the meanings would be listed together under that one entry. Similarly, dictionaries have a unique key, and all the things associated with that key are placed in that key's entry. GIS attribute tables enforce a similar structure. Each record in the table has a unique key. For example, a shapefile attribute table has an FID, and whenever you add a new row to the table, it assigns a unique key, an FID value that has not been used for any of the other records. Keep in mind that, like strings and lists, this is a native Python data type that doesn't have to do specifically with ArcGIS. Next, let's look at the syntax for dictionaries. It's a built-in data type just like strings and tuples and lists. It is also a collection of items like lists, but the items are paired things. They're key and a value, key and a value, key and a value. So, and this syntax is the way it looks when you hard code a dictionary. You use a colon between the key and the value, and you comma separate the items in it, and you use curly braces instead of square braces to indicate that it's a dictionary. And the key has to be unique. It can be a number, it can be a string, it can be some other things, but it's got to be unique. The most common things that we use for dictionary keys are numbers or strings. The value, on the other hand, can be any kind of object, and they can be duplicated. So I could have 0 woods, 1 woods, 2 woods. That would be okay. Just like you can have synonyms in a dictionary. Happy and joyful pretty much mean the same thing. You'd have the same similar definition. Upcoming examples will show how dictionaries can be used to replace multiple elif blocks or to store attribute table records as you loop through them with a cursor. But first, let's look at some more of the syntax. List syntax, we're going to quickly review that. We know how to create an empty list. We did that in the example. A list containing 1, 2, blah would look like this, hard-coded, of course. Add foo to an existing list. How do we do that? Yeah, we can append to remove blah from the list. Yeah, there's a remove method. If you want to get the third item in the list, you would use the index 2. I wanted to point out that indexing is named indexing because it's pointing to, just like the index finger. Check if the 3 is in the list. One way to do that is 3 in my list. That's the most direct way to do it. A lot of this is going to be similar in dictionaries. So to create an empty dictionary, instead of using empty square braces, we use empty curly braces. To create a dictionary that contains these items, we would surround them by curly braces. To add the item 10, lake to the dictionary, we do this. It's not an append for dictionary. If you have an existing dictionary and you want to add a new item to it, the notation that you use looks a little bit like indexing because you do the name of the dictionary object, square braces, the key, that's what goes in here, whatever key you want to add, and on the other side of the equal sign is the value that goes with that key. That's the first big difference between lists that we've seen so far. To check if MyD has an item with a key of foo, there are 2 ways to do it. You can do very much like the list, foo in MyD, and that'll return true if there's a key of foo. That would be the first one before the colon. The other way, there's a method, a dictionary method, which is has_key, and this will return true or false the same way. So it's checking if we is in the dictionary, and that would be false because we don't have that key in there. Though these 2 are equivalent, the has_key method is going to be deprecated in versions of Python 3 or greater, so we may as well start using the in keyword. To get the value of the item, which has key 5, it looks a lot like indexing, though it's not. You would say MyD of 5, and that would give you the value park. It's instead of using an index inside of the square braces, you use the key. Instead of having indexing, dictionaries have access by key. MyD square braces 5 is an example of access by key syntax. When you get or set a dictionary value by using a key inside square braces, this is referred to as access by key. Notice that 5 is not necessarily the 6th item in the dictionary, it's just a key. How would you get the value of the item which has key foo?
In with square bracket. Val1 equals MyD square bracket foo.
Yeah, that's exactly it. Value equals MyD square bracket, the thing you're looking, the key that you're looking for. And that'll give you orch. That's the value that's associated with that item, that key's item. What will this one be?
No.
Yeah, the traceback error, a key error. Because there's no key in this dictionary too.
Key error.
Yeah, it says key error. To delete the dictionary that has key 5, use the del keyword. Del MyD of 5. The dictionary will now only have 2 items in it. We'll take out the one with that key. If you try to del MyD of 2, it's going to give you a key error. It's going to be trying to delete something that doesn't exist.
If you had you said there can only be 1 key with each value.
Yep,
Okay.
that's right.
How do you find if a value is in the dictionary? Is it the same as a key? Like foo in MyD is the same? You just put the value. Oh, you put it.
There's a method that'll list the values. That'll return a list, and then you can look for that in there.
Okay.
There's no hazard with that. That's a good question. If you want to add an item to a dictionary, you can add it, of course, when it's created, hard coding it, and then you can also add it individually after the dictionary has been created. You have to use access by key notation to add a new item. Here we are creating an item that will have key of 10 and value of lake. Because we use access by key notation and it doesn't have that key yet, it will create a new item with that key. Modifying an item that's already in the dictionary looks very much like number 2. You also just say the key that you want to use and the value that you want to give it. 5 park is already in the dictionary. We want to change it to 5 hooray. We just say my D square braces 5 equals hooray. And then we have our updated dictionary.
So is there a way of catching yourself if you are accidentally correcting something versus adding something since they look about the same? That's an easy.
Sure. What could you use? Well, you'd have to use a conditional statement before you do it.
So if the index or the unique value exists.
We went over a way to tell if a key was in the dictionary already. So that was the in keyword.
Okay.
I could have a conditional statement that says, if 5 not in my D equals hooray. So that would prevent me from overwriting an existing item. We're going to use a statement like that in some upcoming slides. Sometimes you want to only add to the dictionary if it's a new thing. Just as lists and strings have methods that are associated with them, dictionaries have methods. The keys method returns a list of all the keys in the dictionary. Note that the order is arbitrary. The has key method, we already discussed that one, returns true or false. The values method returns a list of all the values in the item pairs. And the items returns a list of all the items as tuples, with the first being the key and the second being the value. Well, let's look at some examples. So we have our little hard-coded dictionary here. Predict the value that will be returned for each of these methods for this dictionary. Were your predictions correct? Perhaps your ordering in your predictions was slightly different. This may have occurred because the order in the dictionary is arbitrary, so you don't know what order you're going to get information back. Notice the last one, the items, returns a list of tuples. There are 3 tuples. Each tuple contains the key value pairs. Now we have an in-class exercise to get familiar with dictionaries. Try the code out, go to the schedule and click on the in-class link for dictionaries. You will see a series of commands. Copy each one individually into the interactive window and try to predict what it's going to return before you hit enter. There are also several questions to answer when you finish the exercise.
Yeah. Yeah. It's 12.
What do you think of it? I agree. Care. Oh, I probably changed it.
Yes, because there is no key for number 3.
Yeah, no, it's not. We could do tab condition.
Or is this guy?
It's just random.
That's
It's not random, it's like it starts to go in order and then it wasn't shelf in the order you had.
It doesn't put the parentheses for you.
No, it doesn't.
True.
Do I?
Because there is no one. So this.
Yeah, with the numbers, it's consistent.
Yeah.
This is
Yeah,
not
put the letter in
I think it was
Right.
Yeah, I don't know. That's
I guess not.
not exactly what I expected. I thought it would just put it at the end.
Right. It's not, you cannot depend on the order. If you need it to be in the order that
This
you
one
insert it,
one.
then you need to use a different thing called an ordered dict. But if you use ordered dict, you have to import it in a module.
If you. So now it's other. Yeah, I see a lot of mistakes.
It has an internal algorithm called hashing. Heard of hashing? It's basically a mathematical process that is very
Now we're
quick and
indexing
efficient.
again.
But it means that you don't know what order it will be.
Unless
If we took this from Python 2.7, went to Python 3.5, it might have different order.
All the logic in the head is.
Can you do that?
I don't know. Whatever they, whatever algorithm or comes fast, right, it pretty much like I'm not sure. I just read it.
Yeah, dictionary.
Here. Yeah. Where are we with? So now we do 1 and it should be.
For me, it looks like a list inside in there.
No, I know, I think it's.
Yeah, it's doing a list inside.
Yep.
I wonder if you have to have the brackets though, or
So
you
what
didn't
is
just have them.
Oh, yeah.
Just have like
The whole thing again.
that.
String will be the key.
Oh,
Try it.
And this one's gonna
Oh, yeah.
add.
If you need them to
You
be.
go control up arrow and maybe just
Like these, is that what you're saying?
Yeah, let's say we wanted
control
them
up arrow, yeah.
in the reverse order. We wanted to start at 5. We could do my D dot keys.
So when you use comma separated items without anything around them,
Now we're
it
creating
creates a
an empty list.
tuple. So that's what, remember those curly
Duck
braces
dictionary,
around
sorry.
the
Empty
tuple?
dictionary, yes.
Or lesser used data type?
Well, we have,
I mean, the round ones, this thing right here.
I don't think so.
Well.
Now we're gonna add the key.
So if you say my
It's a
D
list.
here now.
So then we can go dot sort.
So it'll have the key,
Okay, you're on number 6. right?
strk with the value of 5.
So now
Crazy. Yeah, I love
Yeah.
Huh.
Can you just wait? Can we not hide it? It is a list.
Yeah.
No.
yeah, we're
This
next.
is a list.
Yeah.
New list.
So beer's the list, so just do.
Oh, it's beer dot.
Dot
I don't know if that's.
This is not doing what I thought it would do.
So just have to put 0, 1, 2, 5.
Because it's not.
Yeah.
Well, I thought I had a way to
Does
get
it
it.
usually put the numbers before the string?
I mean,
There's a choice that you
Oh.
decide to have.
I thought I I'll show you some.
Oh, I see.
Cool.
Numerical.
I failed.
but since we already exist, can we just do
So can you answer the questions that come up?
added on?
So the first question, what does my D2, if the empty curly braces, it's an empty
With the key,
dictionary?
yeah. D, my D here.
So,
Equals.
and then we typed my D,
I don't
Oh, I see what you're saying.
equals other D, modified the value of key 1.
Make it like a number.
Here is the key.
Beers.
When you just type question,
My list 2 is an index. and
my D,
D2.
say,
I don't think so, because we already exist.
Yeah, but when you do.
Would you mind
Variable.
checking?
It has a
Do it like this.
D,
two and my D.
variable,
Or my D
shows
does
that.
have
So
but my D.
I
is
think it's
versus
probably
two.
a special,
My D.
special rule,
A pen, in this case.
I'm guessing,
uh,
for a variable.
Yeah, I guess you're right. In this case,
With
it's
it.
printed in my D.
But it's things like that. If we say we
Here,
get
it's like.
And that's so that you can do this.
I think it should be a pen. My D.
And the line of code to add the item.
No, not to the left.
Means London and Berlin. So it
Okay,
Well, if you did values, it would return a list without values, and then once we have a list.
So the key
Yeah.
is
So,
London.
To do,
My
dot, and then add our
yeah.
I think it would be N just.
you see, it allows you to use the changing variable as the,
Did you get pen yet?
We were trying to figure out.
Okay.
I think it's a special rule.
Let me ask you this, how do you get
Yeah,
to
so I just
the
put it in
beer,
randomly.
the value of beer? Yeah. Of the beer key.
Now I am pressed.
Associated with beer.
Yes.
How do you get to the value of the dictionary?
I don't-
associated with the beer key?
I'm not sure if I can do it.
But it doesn't have a name.
It's a rule we're gonna have to learn. I mean, I don't know if I find a name.
Oops, just missed a quotation.
I guess the next the
Okay.
so we do that. So that's
Oh, okay.
zero.
Did it?
Yeah.
You explain the difference between my list 2 and my D2.
And then-
List look like.
Yeah.
I don't know what the list had looked like.
Just to see if it worked. We're gonna use that later. And number 7.
Set the value of
Well, it's too big.
5 hours with a line of code to add.
So it's
Okay, got
5.
it. It's the append.
Yeah, 0, 1, 2.
One of those.
And a value
We're gonna use it later, so you have to kind of struggle through it
and
to
value
figure it out
of
the
this
first place.
containing one item. So then x equals
Here are the follow-up questions. What does my D equals empty curly braces do? Well, that creates an empty dictionary. No, it's my D2. So it's an empty dictionary named my D2. When number 2, when you get to these statements when you're going through the exercise, my D was equal to 0 woods, 1 park, 5 orch. That means that the dictionary had a key of 1 at that point, and it did not have a key of 3 at that point. So that means that my D of 1 equals others. Other was a modification to the dictionary, whereas my D of 3 equals lake was adding a new item to the dictionary. So after we say my D of 1, it modifies the existing item 1 park to become 1 other. And after we call my D of 3 equals lake, it adds a 4th item to the dictionary, which would be 3 : lake. The difference between my list 2 and my D2 is that for lists, they don't have key access, they have indexing. So my D of 2 would be indexing into the list, getting that 3rd item since it's 0 based, and my D of 2 is using access by key. So this returns the value of the item in the dictionary with the key of 2. But it tries to, but in this case the dictionary doesn't have a key of 2 at the point where you try that, so it will return a key error. To add an item to the dictionary with a key of London and a value of Heathrow, we would say my D and then square braces, quote, London, unquote, in square braces, equals, quote, Heathrow. Okay, so the key goes in the square braces on the left side, and the value that you want associated with that key goes on the right side of the equals sign. Write a line of code to add an item with key beer and value a list containing Bass, Corona, and Dunkel to my D. So that would have, instead of just a string in quotation marks on the right side, it would have that list with the square braces and the list of items on the right side. Now, number 6, if you wanted to write a line of code that would append another type of beer to your beer list, you could use the append method on that item. So first of all, that item is, the value of that item can be referred to as my D of beer, and then you can, since it's a list, you can do the list append method and append pale ale by saying dot append and put that in the parentheses, pale ale in the parentheses. The last one asks to set the value of x to 5 hours. So we can use an assignment statement to do that. X equals 5 hours. Then write a line of code to add an item with key sleep and value a list containing one item, which is x. So that one is the one where you have square braces on both sides of the assignment statement. Just like in number 5, we were creating an item with a list as its value. In this, we're creating an item with a list as its value, but the list only contains one item, and that item is stored in a variable. So it would be my D, square braces, quote, sleep, unquote, equals square braces x. And now we'll just look for a moment at the code that the group that stood up and did our example in class group exercise used. And then we can move on to some more examples. So number 6, write a line of code to append pale ale to the list. So we had what we had done in number 6 was we added an item, which was this. If you want to add an item that's a list to a dictionary, you can use the square braces on the left for the key and the square braces on the right for the list. Square braces 2 different ways. If you wanted to add an item called foo and set it equal to an empty dictionary, how would you do that? Yeah, just empty square braces. Later on, we're going to add an item to the dictionary that has got a key and it has only one item in the list to start off with. And then we want to add things to that list. There's a lot of different iterations before we got the right one. But if you want to add something to this list that's part of a value in the dictionary, you have to use that append. My D of beer is now a list. And if you think about how to append to a list, it's mutable. It's one of those ones that changes in place the list dot append. And you can do the same thing when the list is in a dictionary. So here we're referring to the list, and here we're appending to it. And then the result is that item has a list that has been appended to, and the dictionary has that value. Dictionaries are good for storing information from GIS attribute tables. Remember last time we talked about search cursors. The first required argument for a cursor or parameter for a cursor is the data, whatever data that you want to, the table or shapefile that you want to refer to. If it's a shapefile, you use the .shp extension. This is assuming we've set our workspace already, so it knows where. The second argument is a list of what?
Field names.
Mm-hmm. A list of the field names for the fields that you want to get with your cursor. So in this example, this is just collecting cover values into a dictionary, and it's using the FID as the key. So you want to use that somewhere else with the data structure. You can do like this. So you can create an empty dictionary to start with. And then, so what are we doing in this? For row and SC, that is doing what? Iterating through the rows. A point at the first row, point at the second row, and so forth. What does this line of code, ID equals row 0, do?
That's where variable ID equals to what was in FID for that row.
Yes, that's the variable ID to the current FID, whichever FID is for that row. First time around it'll be 0, second time around it'll be 1, and so forth. And then, what does this line of code do? Sets a variable cover type to first time through, it's going to set the variable cover type to what?
Woods.
Woods, right? It's going to set it to the value of the cover in that row. So why is it 0 for FID and 1 for cover?
You don't have shape there.
Because this is how I initialize. When I specify the field list, I put the FID in the 0th place and the cover in the 2nd place, in the 1th place. Okay, it's just has to do with the order of how you list the field names up here. And that gives you the order that you index them down here. Okay, so hang on to your hats. Next line of code, what does that do?
Adding into the dictionary, making the ID the key and the cover type the value.
It's adding an item to the dictionary to do with the current row, making the current row's FID the key and the current row's cover type the value. Okay, so what do you have at the end of all this?
A dictionary with the FID is the key and then the cover is the value
Yeah.
for the entire table.
Yeah, it'll be 0 woods, 1 woods, 2 woods, 3 woods, 4 woods, 5 or other, and so forth, right? And what does this statement do?
Deletes the cursor.
Deletes the search cursor object that's in memory. It's your Python object that you need to do, because otherwise your data will be locked. If you started trying to do the homework, you probably already experienced that. Okay, so So in the previous example, the keys were guaranteed to be unique because we were using the FID, right, which is unique, right? That's enforced by the GIS, the shapefile format that it has to have a unique identifying value as FID. But if the key value from the input dictionary is not guaranteed to be unique, as Samantha so greatly brought up a few minutes ago, you have to use a conditional statement for some cases. So you have two cases, like either the key is already in the dictionary or it's not yet in the dictionary. Okay. So then you can do some branching down here. So in this way, we can have the code do two different things for these two different cases. For example, you can create a new dictionary entry and initialize the value to 1. And that's what we're doing down here in the case that the key is not already in the dictionary. And then in the case where the key is in the dictionary, what are we doing here?
We're counting the number of occurrences of the different kinds of entries.
Exactly. Very good. It's a handmade frequency counter. But in this other case, if the key is in the dictionary already, we're adding 1 to our counter for that particular key. Add 1 to the existing values of that item. So this is a frequency example. Let's just maybe step through it. We're doing kind of the same thing as last time. In this case, we've only got one field. We're just grabbing the cover field. So when we say row 0, the first time we're getting what? Woods. The first time the key is woods. We've just gotten in here, so our dictionary is empty. First time around, our dictionary is empty. So we say if key in my D, what's that going to return? False. Yep, false first time around, because there won't be any key with woods the first time around. So we'll go to the else condition. So what is this statement doing? Setting the value of wood to 1, but it's creating a new item. There's nothing to update. It doesn't exist yet. So it's creating a new dictionary entry with woods as the key and value as 1. Then we loop around again. We get to the second row, and key is what?
Woods again.
Woods again. Then we say if key in my D, that's going to return true. So we're going to go inside here. Now what does the statement do?
It increments the value.
Yeah, it increments the value in short. Let's see, what is this right here? My D of key. At this point, what's the value of this right now? 1. It's adding 1 and 1, and it's using an assignment statement to set what? To 2. To set the woods item, key item to 2. Key value item to 2, right? So it's saying, so when we look at the dictionary, it'll be curly braces woods : 2.
So is this basically counting how many woods will be in the
Yep. It goes through and it counts how many woods, but then it gets to, so it'll count up and it'll get 5, right? By row 4. After row 4, it'll get 5. And then row index 5, it's going to get a new case. So
go to else?
It's going to go to else. And then what's our dictionary going to look like?
Woods 5.
Woods 5.
And
Other
1.
Other 1. Mm-hmm. And then it'll keep going, and it'll add if that thing is already in the dictionary, and then it'll start a new item if it's not. A lot of times when the examples that we do, we want to do a different thing. If it's like this is like our base case. Base case, it's not in there yet, start it out, initialize it to whatever we want to initialize it to. And this is, if it's already in there, do something to change it, to modify it, update it. Here's a slightly more complicated example. So the goal on the previous one was to get, this was our final dictionary for the table I've printed here. They would end up with woods 9, porch 3, other 3, assuming this is your entire attribute table. what if we wanted to do something a little more sophisticated with it and say, we wanted to use it to find a list of the areas of the polygons that are woods, covered in woods, and the areas of the polygons that are covered in orchards, so forth. We could do something pretty similar. If you create a dictionary like that has woods and then the lists of areas, you could compute statistics on them, like you could find the mean area, the standard deviation, and so forth. If your goal is to create a dictionary like this where its cover type is the key and a list of areas is the value, then you again need to use a similar structure to the one we used before. But this time we're creating lists in our dictionary. That conditional statement is going to look something like this. If the key is not a dictionary yet, you're going to create a new list with just one item in it. And if it's already in there, you do the same thing that you did for your beer case, which was you said MyD of beer dot append the value. And that'll add it on to your list. So here's an example doing the task that we talked about before. We want to create a dictionary that has woods and then a list of areas, orchards, a list of areas, other lists of areas. We could do a search cursor that has cover and the F area in this case, call that field, and then loop through that. So this one is getting row 0, which is the first time round it's going to be woods. Row 1, since it's the F area, first time round it's going to be about 600,000. So that's going to be our cover and area values, woods and 600,000. Then we say if row 0 and D. Oh, we could have said if cover and D, same thing. What would that be? True or false? First time around. False. So then we would go else, and we would say this. What's this going to do to our dictionary? What will our dictionary look like after this?
Woods, colon, 600,000.
Yep. It'll just be curly braces around woods, colon, 600,000 with square braces around it. And then the second time we loop around, we get a cover of woods again and an area of 1.5 million. And then we say if row 0 in D, so if woods in D, yes. And then we do this. So what's our dictionary going to look like now? In that area. It's going to be woods, colon, it's going to look very much like this down here, except without the dot, dot, dot. Woods, colon, square braces, 600,000, comma, 1.5 million, end of square braces, and that would be the end of the dictionary. We wouldn't have all the rest of this yet. Because what are we doing here? We're appending the current area to the current list that the dictionary has for woods. We went over built-in dictionaries, all this stuff to relate to them. Accessing by key, not by index. It looks like an index, but it's not an index. It's key access. How to update a dictionary, how to add to a dictionary. Adding and updating look just the same syntactically, have a different effect. And deleting, you use the keyword del, the del keyword to do that, and then you access that key, the square braces. You learned about has key, but also alternately to has key, you can use the end keyword. You got lists of keys, values, and items just by using the dot object dot method. Dictionaries, so you know how to loop through dictionaries keys, or you can actually loop through the values, or you can loop through the items in this way. We didn't really talk in detail about that. You can use dictionaries with archive cursors, And next time, we're going to go over reading and writing text files. And we know how to do cursors, and it's kind of similar what we're going to do with reading and writing with text files, but that's for files that may not have that perfect structure that ArcGIS requires in order to read it. So it might have gobbledygook at the beginning, but you can handle that with code. And that's it.